All right, let's solve some inequalities. In order to solve inequalities, first there's a couple of things I need to remind you about. First of all, this is known as an inequality symbol, and this is also an inequality symbol. And this guy has a special name. It's known as the greater than symbol. I've heard some people call it more than. That's fine as well. Let's see here. Let's write that out. And then this guy here is known as the less than symbol. And I will tell you that one common problem that I see that people have is trying to remember which is which. And by the way, this is always the greater than, and this is always the less than. How can you tell which is which? Well, it turns out that this guy is the one that's most easy to recognize. And let me see if I can demonstrate this. I'm going to try to do something tricky here. Of the two symbols, this guy, the less than symbol, is very easy to identify, and I'm going to show you how. It turns out that the less than symbol, if I simply rotate it a little bit to the left, you can see it looks little bit like an L. Notice that? L for less than. I'm going to rotate it back so it looks like the less than symbol we know and love. But you'll notice that if I try to rotate the greater than symbol, it certainly doesn't look like a G, and it never looks like, well, I guess it could. If you rotate it a lot, it could look like an L. But mostly the greater than symbol, if I rotate it just a little bit, it never looks like an L. But this guy, the less than symbol, if I rotate it just a little bit, you can see it looks like an L. So that's how you always know which one's called less than and which one is called greater than. Of course, we have other things going on. Don't forget that there's your greater than symbol can have like a line underneath it. And if it does, then we call that greater than or equal to. And if we have the less than symbol, it can have a line underneath it. And if it does, we call that less than or equal to. And let me go ahead and get those. So there you have it. I've written out the definition of the greater than or equal to symbol and the less than or equal to symbol. If you want to pause the video and write that down, that'd be great. I'm going to go ahead and get started and show you just a very simple inequality. We're going to solve it. One of the nice things about the lesson on solving inequalities is it's a good opportunity for us to review some of the properties that we need to know for solving equations as well. In this particular case, here's an inequality, and I still want to isolate the variable just as though I'm solving an equation, and I'm still going to use some of the similar techniques. I've got a 2 down here, and I need to get rid of it in order to isolate the variable. And the way I'll do that is I'll multiply both sides of the equation by 2, and when I do that, I get rid of the 2 on the left-hand side. It cancels. This 2 over 1 cancels with that 2. And so I can go and I can write x plus 3 is less than 10. And then I can go ahead and add the additive inverse to this 3 to get rid of it. And using the addition property of equality, I can go ahead and I can do that to both sides. Now, when I add the additive inverse of negative 3, when I'm adding negative 3, it's just like subtracting negative 3, so I'm going to write that. So that gets me x plus 0, but I throw away the 0 because it's the additive identity, and then is less than 7. Now, something that's kind of new, and my 7 looks a little bit too much like a greater than symbol. Let's go ahead and see if I can write that 7. There we go. That's better. So x is less than 7. Now, that's the solution to my inequality. But there's a little problem with this. The problem is that really x has many, many values here. And if I wanted to list all the values, a lot of times what I would do is I would write a set. And in this set, I would write all the possible solutions to my equation or my inequality. So in this particular case, x is less than 7. So I could start listing numbers like x is 6, or 5, or 4, or 3, or 2. And I could keep going like that, all the way down into negative numbers. But no matter what, I would have to write dot, 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 because the problem is that there's so many numbers I can't list them all. There's also another issue here. If I write 6, 5, 4, 3, 2, are there any values of x that could be in between 6 and 5, or 5 and 4, or 4 and 3? Well, yeah, there are. So this idea of writing the solution set for this inequality in this way, it's just not that great. It's not the preferred way to get the job done. So instead, what we do is we'll write this out as a graph. And here's how we graph this thing. What we usually do is somewhere on the graph we'll mark 0, and somewhere we'll mark the number 7 because it's important in this case. So I'm going to go ahead and say that my 7's there, and I'm going to say that my 0 is right about here. And the main thing is that when I put numbers on the graph, they should be spaced in such a way where it looks like if there's more than one number, they should have the appropriate amount of space between them. Well, I should say if there's like 3 numbers, like if I wanted to write -1, I shouldn't write it way over here like the 7. So if I wanted to write -1 here, it should be reasonably spaced compared to the 0 and the 7. Also, if I like putting 0 on the graph because it tells me where the 0 is with respect to the number that we're interested in, which in this case is 7. Now, the next thing that we're going to do is we've got to put a dot on this graph, and I'm going to put the dot right here where the 7 is, and I'm going to make the dot an open dot. I could fill that dot in, but I'm not going to in this case, and I'll tell you why in a second. And then the other thing is I've got to indicate where all my solutions are. And by the way, this is an open dot because there's no solutions here. But my solutions are all values where x is less than 7. So for that reason, I'm going to go ahead and draw an arrow to all the numbers that are less than 7. Now, some of you might notice that the less than sign here is pointing in the same direction as the arrow, and that's not really a coincidence. That's pretty much a pattern that's true. But the most important thing is for you to realize that this line and this arrow indicate where all the solutions to this inequality are. If this graph is a solution to the inequality, and I believe that it is, this is the best way to write the solution to this inequality, then all of the individual points that are on this line, if I go to pick any point, whether it's 6.5 or 4.2 or 3.5, those points better darn well be on this line because they are all solutions to the inequality x is less than 7. Okay, now, what about this open dot? It turns out that whenever I have a greater than symbol, when I'm graphing, I will go ahead and use an open dot. And a less than symbol, I will also use an open dot. And if I have a greater than or equal to symbol, I will use a closed dot. And for a less than or equal symbol, I will also use a closed dot. So this is what we'll use when we're graphing, and this is known as an open dot, just sort of to contrast with the idea of the closed dot. And also this is known as a closed dot, or it's also known as a filled dot. And that probably makes a little more sense, but we also call it a closed dot. And one way to remember whether we need to use an open dot or a closed dot is this thing right here. This guy, this underline underneath my less than symbol and the underline underneath the greater than symbol, that guy is going to tell us when we have a filled in dot. And the way that it's going to relay what we need to know is that if I have this line underneath my inequality symbol, then I'm going to fill that dot because we're going to pretend like that line is a crayon. And anytime I have a crayon in my inequality symbol, in my graph, I'm going to fill in the dot. And if I have no crayon, then I will not fill in the dot. And hopefully that's something that you can remember. I don't know about you, but if you're like me, then you have a love of crayons. And if you do have a love of crayons, then this is going to make it a lot easier to remember. Remember that lovely, beautiful set of crayons with all their colors? So fun. The box of 64 with the little plastic sharpener. Well, if you have one of those babies on your inequality symbol, you're going to fill in the dot with it. And if you don't have a crayon, if you have none, then you will not fill in the dot. Okay, let's progress. So let's take a look at solving another inequality. And again, I'm going to try to remind you of some properties and techniques that we use with solving equations when we're doing this. First of all, I would like, for solving this inequality, I want to isolate the variable x. And to do that, in this particular case, I will begin by getting rid of this -5. And to do that, I will add the inverse of -5, which is +5, and I'll do that to both sides of the inequality, just like I must do with an equation. You got to do the same thing to both sides of the inequality symbol, or the equal sign. So when I do that, I end up with -2/3 x plus 0, but I'm going to throw away the plus 0 because it's the additive identity, which means that -2/3 x plus 0 is just -2/3 x, and then I'll leave less than or equal to, not 7, but 12. 7 plus 5. Now, I still want to get the x all by itself, and in order to do that, I got to get rid of this -2/3. And one way I can do that is by multiplying by the multiplicative inverse. And the multiplicative inverse is also known as the reciprocal. And in this case, it's -3/2. So I'll multiply the left-hand side by that, and to make it legal, I have to multiply the right-hand side of the inequality by that as well. And again, some of you may repeat back to me that you're doing one thing to one side and one thing to the other, but some of you are not entirely sure what we're talking about when we say sides. When we say sides, we're talking about sides of the inequality symbol. Please make sure that you get that. Okay, so anyways, after we go ahead and we do that, if we multiply the multiplicative inverse times a number, then we just get 1, and 1x is just x. And then because we're multiplying both sides by a negative number, we're going to go ahead and flip this inequality symbol around. Next, we're going to multiply the 12 times -3/2. That's going to be a negative number for sure, positive times negative. And if you remember, we can really put that 12 over 1, and that means 12 divided by 2, which is 6, times 3. That gets us 18. So I end up with x is greater than or equal to -18. And this is the solution to my inequality, and but remember, I need to really graph it. So let's graph this guy. Now, as I said before, I'm going to go ahead and put the -18 somewhere on this number line. And just so that I'm aware of what's going on, I'm going to go ahead and put the 0 so that I can get my directions here, my bearings. So anyways, let's see, now we need to do a graph. And when we go to do the graph, we're going to say, well, this is an or equal to sign. So since I have, also that's known as a what? Yeah, it's a crayon. So because of that, when I go and put my dot here, I'm going to have to go ahead and fill it in. Don't forget about the crayon. Okay. Next, I either have to draw a line to the right or to the left. And when I draw that line, the goal is to make it so that all the points that are on the line are solutions to this inequality. That's what solving is all about, getting solutions. getting values for x that make this statement true. That's true with inequalities, and that's true with equations as well. So let's see here. If x is greater than or equal to negative 18, then that must include numbers like negative 17, negative 16, negative 15, negative 14, 0, etc. So for that reason, I know that my arrow must go to the right. And it's no coincidence that my greater than symbol is pointing to the right. So this is two ways to show the solution for this inequality. Let's take a look at another one. Here's another problem that's kind of interesting. It's an inequality. I'd like to solve it. I'd like to isolate the x and find the values that make this statement true for x. So the first thing I'll do is I'm going to go ahead and I'm going to subtract 7 from both sides. And let's see here. So by the way, that's like adding the additive inverse to 7 to get 0. So I'll go ahead and add the negative 7 here as well. That gets me a negative 4 over here on the left of the inequality symbol. And on the right hand side, it leaves me with 5x plus 0. And I just throw away the 0 because it's the additive identity. Now, what about this greater than symbol? And by the way, notice I know that it is a greater than symbol. We are subtracting from both sides. So should we flip the greater than symbol? Think about it. Another thing that's kind of interesting is the result on the left-hand side is now a negative number. Does that indicate that we should flip the inequality symbol? Well, I'm going to tell you, so pause if you want a moment to think it over. But here's the deal. We're not going to flip the inequality symbol. It turns out there is a special situation where we flip the inequality symbol, and I actually showed you that in the previous example. We only flip, and I'm going to go ahead and write this out, and you should write it down. Only flip the inequality symbol when you're multiplying both sides by a negative or dividing both sides by a negative. Alright, so it'd be really wonderful if you took a moment and added this to your notes. Only flip the inequality symbol when multiplying or dividing both sides of the inequality by a negative number. Okay, when that occurs, we'll flip the inequality symbol. Not when we're subtracting, not when the result is negative, but only if we're dividing or multiplying both sides by a negative number. You can go ahead and pause and write this down, and I'm going to go ahead and start back up on the problem over here. So the next step is I'm still trying to isolate the variable, so I'm going to divide both sides by 5, just like I would if this were an equation. And when I do, I end up with negative 4/5 is greater than x. Now that is something that really is the solution to my inequality. And one of the things that I'd like to do is I'd like to graph the solution as I did before. So let's go ahead and do that. I'm going to go ahead and put down some markers here. First of all, here's my 0. And in this case, I think I'm also going to put a 1, just so I have some idea. We'll put a negative 1, I'll say, just because I want to have some idea as to where that negative 4/5 is. This is something I'd like you guys to practice with, is where do decimals show up on the number line and where do fractions show up. In this case, negative 4/5 is almost all the way over by negative 1. It's important for you to know that, because when we do compound inequalities, you might have to put several fractions on here, and you need to know which one is greater and which one's less. So anyways, there we go. Now I'm going to need to put a dot here where the negative 4/5 is, and the question is, do I put an open or a closed dot? Pause for a moment, think about it, and in a second I'm going to tell you. Alright, hopefully you figured out that you're going to need to put an open dot. And you remember why. Yes, hopefully you're saying what I'm about to say. Pause it if you don't want to hear it. There's no crayon, so I will not fill in this dot. Okay, so the next thing is I now want to make a line, and I either go to the right or go to the left. And for those of you who like memorizing things, you may notice that this arrow goes to the right. And you very well might want to go ahead and just draw your arrow to the right. However, if you do that, bam, you are wrong. That is absolutely incorrect. That's why memorization doesn't help that much in math class. We really got to understand the concepts and why things work the way they do. Um, what we're really saying here is that negative 4/5 is greater than x. So if that's what we're saying, then x must be all these values, must be all these values over here, because negative 4/5 is greater than x. So x is all these values that are less than negative 4/5. Now, another way that we can visualize the correct thing is with the arrow, is we could just rewrite this guy. We're allowed to flip this around so the x is on the left and the negative 4/5 is on the right. But unlike in equations, you can't flip the thing around and leave the inequality symbol facing the way that it's facing. Equations have the symmetric property of equality, which means that you can just flip them around and leave the equal sign. But inequalities are different because x is smaller than negative 4/5. So whatever I do, if I change x in negative 4/5 position, I have to write an inequality symbol that continues to indicate that x is smaller than negative 4/5. So I'm going to go ahead and write the less than symbol. And you'll notice now when I have the variable on the left-hand side of the inequality, the arrow of the inequality matches up perfectly with the arrow of my graph. All right, a bunch of little tidbits in there for you. Hopefully that was helpful. Let's see if we have one more. In this example, I'm showing it to you less to educate you about inequalities and more to remind you about techniques that can be used to solve equations. So that's the main reason for going through this, but we're going to do it with an inequality regardless. Now I want you to notice something interesting about this problem. In this problem I have both an x and a y. And what we're going to do is we're going to try to solve for y. This is something that we had to do in a previous section on solving equations. And we'll need to do this very soon when we try to graph linear inequalities. So anyways, so here we're going to get some practice. So what we're going to do is try to isolate this y. And when we do, we'll say we have solved the inequality for y. Now, the way we're going to do it is we're going to try to isolate this variable y. And for many of us, our first thought is, well, let's get rid of this negative 32. But that's illegal. You cannot. What we really need to do is we need to get rid of this 5/9 over here. If we can strip that away, then we can get rid of the 32. So whenever you're solving equations or inequalities, you always try to strip out the outside layer first, and then you can strip out the inside. So the first thing we'll do to get rid of this 5/9 is we'll multiply the entire right-hand side of the inequality by the reciprocal of 5/9, also known as the multiplicative inverse, 9/5. And in order to make this legal, we'll do the same thing on the left-hand side of the inequality, multiply by 9/5. Now, just to make it very clear how this works, I'm going to go through this step by step, and some of you need this and some of you don't. I'm going to go ahead and rewrite the inequality symbol, but I'm going to use the commutative property of multiplication to move the 9/5 to the front. So this will be 9/5 times all this other stuff. Now, one of the reasons, well, you'll see in a minute why I want to do that. The next thing that I would like to do here is I would like to throw away these square brackets. And the property that allows me to do that is known as the associative property of multiplication. If I'm multiplying a bunch of things together, which I am, 9/5 times 5/9 times y minus 32, then I am allowed to regroup in any way I like, and that means I can even throw away the parentheses. So this turns into 9/5 times 5/9 times y minus 32. And hopefully you see where I'm going with this. The idea now is that 9/5 times 5/9, those guys are multiplicative inverses of each other, which means they turn out to be 1 when I multiply them together. And part of that is because the 5 cancels with the 5, and that gets me 1 and 1, and 9 cancels with 9 and gets me 1 and 1. Anyways, in the end, what I am left with is just the y minus 32. Now, a common mistake that students will make is they'll realize they got to get rid of the 5/9, they'll use the 9/5, but they'll try to distribute the 9/5 times the y in the 32. There's no reason to do that. If you use the commutative property to move the 9/5 to the front and the associative property remove the brackets, you will see that I only need to multiply the 9/5 times the 5/9. I don't need to multiply it times the y minus 32 as well. And if you don't believe me, just think to yourself for a moment about this problem. If I have 2 times 3 times 4, do I have to multiply the 2 times the 3 and the 4? I think the answer is no. All right, so anyways, let's finish off this guy. We have 9/5 x on the left-hand side, and I'm trying to solve for y. So I'll go ahead and I'll add 32 to both sides, the additive inverse of negative 32. And when I do, I will then have, over here I'll have 9/5 x plus 32, and that'll be less than y, y plus 0, but the additive identity says that's just y. And then one last thing I'll do, just like in previous examples, I'm going to go ahead and flip this around so what I solved for is on the left. And when I do that, what I end up with is y is something 9/5 x plus 32. So again, what are you going to do? I'm going to let you, if you want, you can pause this and try to think about what are you going to put here? What kind of inequality symbol? Go ahead and pause, and then you can get back to me. Okay, hopefully you agree with me that we need to spin the inequality symbol around because y was greater than here, and so therefore y must be greater than here. So we end up with y is greater than 9/5 x plus 32. Voila! We cannot graph this yet. We're going to learn how to graph something like this. But I thought that this would be a good example of going through some extra equation stuff. And I also thought it might be nice to try to solve an inequality with 2 variables. As far as graphing, we'll learn how to graph this in a later section.